Hello dear students, once again welcome to this YouTube channel. So in previous class we have discussed about the magnetic force. So the magnetic force on a moving charge is Q times V cross B, and electric force is Q times E, and magnetic force is Q times V cross B. Q times V cross B, where V is the velocity of the charged particle and B is the magnetic field. Okay, see in this figure the direction of V, B and F given. So the direction of F is perpendicular to both V and B as shown in this figure. Cleared? Okay. So this magnetic force which depends on Q, V and B, it means charge of the particle, velocity and magnetic field. That force on a negative charge is opposite to that of positive charge. The force on a negative charge is opposite to that on a positive charge. The magnetic force, that is Q times V cross B, includes a vector product of velocity and magnetic field. The vector product makes the force due to magnetic vanish, means become zero if the velocity and the magnetic fields are parallel or anti-parallel, because all of you know the cross product of two vectors is zero when they are parallel or anti-parallel. It means the angle between the vectors are zero. And also the force acts in a direction perpendicular to both the velocity and magnetic field. Its direction is given by the screw rule or right hand rule for vectors or cross product. Already all of you studied. A and B are the two vectors and C is the cross product of A and B, that is vector C equal to vector A cross vector B. Then the direction of C is perpendicular to A and B. Okay, right hand rule you can use, or you can use screw rule. Okay, so now the magnetic force is zero. See, the magnetic force is zero if charge is not moving. Only a moving charge feels a magnetic force. It means the magnetic force is zero if charge is not moving. It means the velocity is zero, then it will not experiences any force. Cleared? So it means when a charge is kept in a magnetic field, it will not experiences any force. So only the moving charge is experiencing a force. So now the expression for the magnetic force helps us to define the unit of the magnetic field. If one takes Q, F and V all to be unity in the force equation, okay, Q times V cross B is QVB sin theta, where theta is the angle between V and B. Cleared? So next point, the magnitude of magnetic field B is 1 SI unit when the force acting on a unit charge means having 1 coulomb charge moving perpendicular to B with the speed of 1 meter per second is 1 Newton. So it means if B equal to 1, V and B are perpendicular and Q is 1. Perpendicular means theta is 90 degree. So sin 90 value is 1. Okay. So V is 1, Q is 1, B is 1. So definitely we will get F is 1 because the expression for the magnetic force is QVB sin theta. Okay. The magnitude of the magnetic force is QVB sin theta. Sin theta is 1 when V and B are perpendicular. Okay. So then the force is 1 Newton. So dimensionally B equal to F divided by QV. So therefore, and the unit of B are Newton second per coulomb meter. This unit called Tesla. Okay. Tesla is the SI unit of magnetic field. Okay. If the force experienced by unit charge moving with unit velocity perpendicular to the field is 1 Newton, then we can say that field is 1 Tesla. 1 Tesla. Okay. And some other units are means non-SI units, smaller units. Gauss means 10 raised to minus 4 Tesla. The Earth's magnetic field is about 3.6 into 10 raised to minus 5 Tesla. Okay. So this is about the magnetic force and the field. Okay. Now see in this motion in a magnetic field. Here there is a magnetic field B. We can say it is uniform magnetic field B, and the charge Q is moving in a magnetic field B, and the direction of V perpendicular to B. So then what happens? That charged particle experiences a force, and which is perpendicular to V and B, and the magnitude of the magnetic force is Q times VB. If theta is 90 degree means QVB, simply you can say it is QVB. Cleared? Okay. And the direction is perpendicular to B and V. Okay. See in this figure, V and B are perpendicular. F is also perpendicular to B and V. So it means suppose the direction of the force is along X, V is along Y, then definitely F is along Z direction. Cleared? Okay. So now let us to discuss some important points here. If V and B are perpendicular, just we have discussed. The perpendicular force acts as centripetal force and produces a circular motion perpendicular to the magnetic field. The particle will describe a circle if V and P are perpendicular to each other. Next one, if velocity has a component along B, this component remains unchanged as the motion along the magnetic field will not be affected by the magnetic field. The motion in a plane perpendicular to B is as before a circular one, thereby producing a helical motion. It's like spring type motion. Okay. We have already learned in earlier classes that if r is the radius of the circular path of a particle, then the force of mv square by r acts perpendicular to the path towards the center of the circle and is called centripetal force. If the velocity is perpendicular to the magnetic field, the magnetic force is perpendicular to both V and B and acts like a centripetal force. It has a magnitude of QVB, and by equating these two expressions for centripetal force, that is mv square by r and QVB, okay, mv square by r equal to QVB, okay, that is mv square by r equal to QVB, which gives r equal to mv divided by QB. See, for the radius of the circle described by a charged particle, the larger the momentum, the larger is the radius and bigger the circle described. Clear? So it means if momentum is more, we are getting more radius of that circular path. If omega is the angular frequency, then V equal to R omega equal to V divided by R. And also we have known omega equal to 2 pi by T or 2 pi mu. Mu is the frequency. Okay. So omega means V by R. Okay. V upon R. From the above equation, R equal to mv divided by qb is there, no? Equation number 6. By using that, V by R is qb by m. So therefore omega is qb divided by m. Clear? So which is independent of the velocity or energy. Here mu is the frequency of rotation. The independence of the independence of mu from energy has important application in the design of cyclotron. Okay, the time taken for one rotation is, that is period, you can say, 2 pi divided by omega, and 2 pi divided by omega are reciprocal of frequency. Clear? So just note down the important points. motion in a magnetic field. Cleared? So in next class we can discuss about the remaining part of this, that is magnetic force on a current carrying conductor. Okay, thank you.